Well, hi everyone. Welcome to our new unit, Unit 10. I'm so sorry that I'm not there with you today. I'm homesick, but I know you guys will do great with this. It is more of a review than it is new information. So we're going to start our Unit 10 kind of in the middle in the 10-2s section. As you can see, we're going to talk today about equal values, which is something we did a really long time ago. I want to say it was actually Unit 4. And then tomorrow and Wednesday, we're going to add on to some additional information. So what we are doing is we are solving a system of equations. So let's get into the work. It's important to understand what our learning target is so that we can make sure that we are hitting that and we can go back and understand what the purpose of our learning is for the day. So today, our learning target is that I can solve a system of equations using the equal values method. It is lesson 10-1. So again, back to Unit 5, we solved a system of equations that were in the format of y is equal to mx plus b, and we use a method called the equal values method. In Unit 10, we're going to continue that work, but again, like I just said, we're going to expand it to using systems of equations that are not currently in the y equals mx plus b format and find additional ways to solve that are not horrible and that do not leave us with fractions. Yuck. So again, this should hopefully be a review, but if it's not, please make sure that you pause this video and put this in your classwork notebook. Writing it down is a great way to make that mental connection with the learning. It is more of a connection than reading it and assuming you'll remember. The act of writing down helps you remember things. So moving into what we're doing, the equal values method is present when we have two equations that you can see are both equal to the exact same amount. So if you take a look here, we have y is equal to and y is equal to. So since y is the same in both equations, that means that since they're both equal to y, as you can see, they are therefore equal to each other, creating this type of equation, which is something that you came into class in September understanding and being able to solve for the value of x. You did not know at the time that these were two linear equations that were both equal to y, and we were just beginning our solving of systems. So let's solve this system for the value of x. So what we want to do is we want to move all of our x's by creating zeros. So here's our first intentional 0. Obviously, you know how to do this, but we will take our time and make sure we're 100% proficient with this learning. That results in 2x plus 5 on the left-hand side and a 19 on the right-hand side. We want to move this 5, so we're going to add the opposite, which is the negative 5. You do not need to circle it. And that results in 2x is equal to 14. The rule says when you get to this step, you divide by the coefficient of x, whatever that happens to be. You'll carry the negative value with you, of course. So then x is equal to 7. All right, so that's great, but what we need to do is we need to find the value of y, and then we need to check both of our values. So again, I want you to understand that you have to show me all of these steps. You cannot move two things in one line, and you must show the division. A lot of you are getting, I think, a little bit comfortable with this idea of solving in your head. I need that work on paper, please. So let's move into, you can choose either equation in order to solve for y, but whichever one you choose, you will use the opposite to check. So I'm going to use this very first one, number 1, and I'm going to solve y is equal to 3x plus 5 when I believe x is equal to 7. So y is equal to 3, and then you will show the parentheses. That is a standard. And then y is equal to 21 plus 5. So we hope that y is equal to 26. So let's now check to make sure that both of our solutions are correct. So we're going to check, and we're going to use this equation right here. That's supposed to be a star. So we're going to check when we believe that x is 7 and y is 26. So we have y is equal to x plus 19. We believe that y is 26 when x is 7. And we are correct. And that is how you get full points. So if you were wondering if this was on a test, and it absolutely will be, what do my point structures look like? Well, there would be plus 2 points right here because you are solving and there's a lot of work. So you get 1 point right here for the answer, and then you get 1 point here, excuse me, for all of the work. Excuse me. You get 1 point here for solving for y, and then you would get 1 point here for checking your work. But we're not quite done, because the last thing I need you to do is I need you to tell me that the point, the POI, would be equal to 7, 26. And that's what I'm asking for. What is the point of intersection? If there is one for these two linear equations, that is also equal to a point. So as you can see, this is a plus 5 point problem. So shifting gears a little bit, we're going to go back and we're going to practice our graphing equations, So it says that you want to graph in one color and then in a different color. I want you to understand that it's important to graph in multiple colors so that we can really identify the lines and make sure that they're correct. So again, we'll start with red, and we always want to start with the y-intercept, and then we want to understand what's happening with our line. We know that this line has a negative slope, therefore this line is going to end up going down as we read from left to right. So we want to find the value of 0, 5, and we're going to put a dot there. That's where we start. And we are going down 1 and over 2. So I'm going to change over here to highlighter. We are going down 1 and over 2, and that is going to be our first dot. And we've created a nice little growth triangle. And then again, we're going to go down 1 and over 2. And again, that creates another lovely little growth triangle. And we could continue this. So down 1 over 2, and then down 1 over 2, down 1 over 2. But what I want you to understand is it's important to go backwards too, so that you can continue the line on the left-hand side. So to go backwards, we would go over 2 and up 1, and that would be a point that we would place. And then we would do it again. We would go over 2 and up 1, and that would be another point that we would place. I'm going to draw a line. It's not going to be as pretty as you because this is not notability. But there we go. We are straight through. Please remember that this is a line, not a line segment. Therefore, it must have arrows at the end, and it must go through the totality of the graph. So there we go. There's our red. So let's go ahead and switch over to blue. We do not have anything here for the plus or the minus, but we do have a slope. So hopefully that is an indicator for you that because there is no b, b would equal 0. And this rise over run would be 2 over 1. So let's go ahead and get into our graph. The first thing we want to do is place a dot right here at the origin for the zeros. And then again, we are going to rise up. We are in a positive value, so we are going to rise up 2 and go over 1. And that's our first point. And we'll do it again. We're going to rise up 1, 2, and we're going to go over 1, and there we go. We have found our point of intersection. You need to keep going because this is a grip out, graphing the lines, up 2 and over 1. And then you could keep going, up 2 and over 1, up 2 and over 1. And just like with the red line, we want to come back. So we want to go over 1 and then down 2 and put a dot there. So we're just going the opposite. And then over 1 and down 2 one more time. And there we go. Now we're going to draw a line. Hopefully it's going to be nice and straight through the totality of our graph, adding those nice arrows at the end so that the reader knows that this is a line segment, not a line. And then because we have a graph, we need to circle that point of intersection with a different color. And we want to label that this is the POI. And that point of intersection is 2, 1, 2, 3, 4. It is 2 and 4. So now it says to show how to solve the point of intersection symbolically using equal values method. So that's what I want to challenge you to do. is to set these two equations equal to each other. Since they are both equal to y, you could end up with an equation that looked like negative 1/2 x plus 5 is equal to 2x. Now, if I was doing this, I would immediately change this to negative 0.5x plus 5 equals 2x. And then I would just do this. I would not get myself involved in fraction busters. I don't know if you can see where I'm going. We'll have to see. 2.5x, and then we're going to divide by 2.5x, and then x is going to equal 2. You would go back in, you would substitute the value of x for y, and then you would check it. I would use this equation. Y is equal to 2 times 2. And you would keep going. And then y is equal to 4, which is lovely because that's what we thought it was. And then lastly, you would do your check with the other equation. So y is equal to negative 1/2 x plus 5. And we would have 4 is equal to negative 1/2 times 2 plus 5. So y is equal to negative 1 plus 5, and y is equal to 4. And that's how you check using the equal values method. Lots of points associated with a problem like this, of course. So in addition to graphs and actual linear equations, we're going to use the word problem as an example for our systems. So the rules for writing linear equations is that we are going to find the y-intercept, the slope. We need to pay attention to the slope in the word problem. Is it negative? Is it positive? We're going to write an equation, y is equal to mx plus b, and then we're going to go back and do it again for the second line. Once we get 2 lines, then we are going to set them equal to each other and follow all the processes that we have done already. So let's give it a try. So this is problem 10-40 from our class book, and I'll give you a moment to read it. Okay, so what we're going to do is we're going to use blue or red and green, and we're going to write 2 equations. So let's start with Team Sunshine. So we know that we want to have an equation, and let's take a look at Team Sunshine. Team Sunshine is filling a pool with a garden hose. The pool has 30 gallons in it, and they're adding 8 gallons per minute. Okay, let's take a peek at the Breezy. So the pool is already filled with that, and they are emptying. That is very important, at 5 gallons. Hopefully you can make that connection that this is our negative right here. Okay, so the first thing we're going to want to do is define each of our variables. So we're going to write an equation to represent each team, and we're going to use the equations to find out how long it takes both pools to have the same amount of water. So that is our key, both pools to have the same amount of water. So we're going to have a y variable, we're going to have an x variable. The y variable is going to be the amount of water. And the x variable, so we're going back up here, we're adding this per minute. So the x variable is minutes. So then if we go back to each of our individual equations, if we take a look at Team Breezy, we have y, which is what we're solving for. And where does it start? It has 30 gallons to start, and it's adding 8 gallons per minute. So that's your first equation. And then if we take a look at Team Breezy, again, we're going to have y is equal to, and what's happening? We're starting with this, but we're emptying. So we're emptying 5 gallons per minute, and we started with 180. So let's transfer both of those. We're going to move over to the next slide, and we're going to solve. Okay, so here's our 2 equations, and we know that because both of them are equal to y, they can be equal to each other. So we are going to write a new equation, and we are going to solve that for x. So we have 8x, whoopsie, erase that. We have, I did it again, jeepers, sorry you guys. I have 8x, one more time. Okay, this time for sure. Here we go. 8x plus 30 is equal to minus 5x plus 180. All right, we're going to move the 5, intentional 0. We have 13x, which makes me nervous. 13 is a prime number, and it's not a great number to work with. We are going to subtract 30. And then we have 13x is equal to 150. And then we're going to divide by 13. And we're going to get x is equal to a horrible number, but we are going to round that to 11.5. Remember, the book problems are always yucky when it comes to numbers. So let's go ahead and see if we can find a value for y that's going to work for us. So let's use our team sunshine. So we will come up here, and we have y is equal to 8x plus 30 when x is equal to 11.5. So y is equal to 8 times 11.5 plus 30. Y is equal to 92 plus 30. So y is equal to 122. All right, let's go ahead and plug that in, and we will check it with the Team Breezy equation. So we are checking the values of 11.5 and 122. So here we go. We have y is equal to negative 5x plus 180. And we hope that we have 122 is equal to negative 5 times 11.5 plus 180. We get 122 is equal to negative 57.5 plus 180. And we get 122 is approximately equal to 122.5, which is fine. So we will never give you a problem that is like this, but the point was to be able to solve an equation that you have written yourself and check the solution. Okay, so we're going to do this again. So I'm going to give you a few minutes to read through, and then I would like you to write the equations and then meet me back on the next page. Okay, so this is a little bit more challenging than what we've done before. The problem actually gives you some hints, and it says to let T be the number of taffy bags and C be the number of caramels. So we're going to end up with two equations. I think it's easier to start with the second equation, and that is going to be the one that is the taffy is equal to something. So if we go back and we take a look at the last part of this, it says that the number of bags of taffy was 5 more than the number of bags of caramel. So taffy is equal to 5 plus C for the caramel. So that's going to be our first equation. And then our second equation is going to be this idea of how each one weighs a certain amount and then the total of the weight. So we're going to have an equation that's not going to be equal to T. So we're going to have 8T for 8 ounces of taffy plus 16C for 16 ounces of caramel. And then that's equal to 400, which is the total number of ounces for each one of the types of candy. So let's go to the next slide and see if we can solve these. Okay, we're going to skip this slide. And here we go. So here are our two equations. We have already set up one of these two equations, as you can see, to be equal to T. So let's go after the second one, and let's solve this one for T also. Then we can set them equal to each other, and we can go ahead and solve. So if we want to solve for the T, we're going to subtract the 16C from each side. That's going to leave us an equation that has 8T is equal to 400 minus 16C. We'll divide by that coefficient, making parts of fractions so that we don't forget to do both. So T is going to be equal to 50 minus 2C. And now we have two equations that are both equal to the value of t, and we can set them equal to each other, and we can solve. So let's do that. We have 5 plus c is equal to 50 minus 2c. We'll make our intentional 0. We have 5 plus 3c is equal to 50. And then we have a negative 5. 3c is equal to 45. We divide by that rich coefficient. And then c is equal to 15. So the caramel is equal to 15. We need to go back into our equation, and we need to solve for c. Solve for t, excuse me. I would go back into this one because it's already set up for t. So t is equal to 5 plus c when c is equal to 15. So t is equal to 5 plus 15. So we think that the toffee is equal to 20. Now we're going to go back into this equation that we carried over, and we are going to check. We are checking when we have 15, 20. Okay, so we have 8t plus 16c is equal to 400. We have 8 times 20 plus 16 times 15 is equal to 400. Okay, so we have 160 plus 240 equals 400, and we have 400 is equal to 400. So what do we have here? We have a POI of 15, 20. And there you go. So hopefully that made sense. And the next thing you need to work on is your RMP. I would like you to only do the equal values today and then the word problems. The equal values are the first ones, and then the word problems are at the very bottom. And we will work on the next 2 types of solving systems of equations tomorrow and Wednesday.